Earthquakes, able to bend and twist the very fabric of the earth, shaping the iconic landscapes we know today. New Zealand, a rugged and raw land, battered and torn by the great tremors which so often bombard this country. An earthquake can be defined as a sudden motion in the Earth's crust, caused by the abrupt release of accumulated stress along a fault. Roughly 20,000 earthquakes occur in New Zealand annually. However, on average, only 250 are strong enough to be felt. The Earth's crust is divided into sections that form tectonic plates, which are constantly grinding into or alongside one another and building up seismic energy, the catalyst for earthquakes. Earthquakes are prone to areas in which two tectonic plates meet. New Zealand lies on the boundary of the Indo-Australian and Pacific plates, thus making it a hotspot for seismic activity. These two tectonic plates form two subduction zones in the south and the north of the island. Subduction zones are the result of convergent tectonic boundaries where two plates collide. The more dense plate subducts below the less dense plate, where its crust is pulled into the mantle and the material is melted, forming magma below the Earth's surface. This intense process of friction and heat generation causes a buildup of stress and energy in the rock, which is eventually released as an earthquake. New Zealand is situated on the cusp of the Ring of Fire, a highly active seismic zone around the Pacific Ocean, where many of the world's major tectonic boundaries occur. The location of New Zealand's earthquakes coincide with the subduction zones. In the northeast, the oceanic Pacific plate is subducting beneath the continental Australian plate. However, in the southwest, the Australian plate is subducting beneath its oceanic counterpart. As a result, the North Island's deep earthquakes occur in a well-defined band between Marlborough and White Island, whilst the deepest earthquakes in the South Island occur southeast of the seismic zone, where the Benioff zone slopes steeply. Volatile tectonic activity is responsible for the formation of much of New Zealand's landscape, through the processes of mountain building and upwelling as a result of tectonic collision and pressure release. Whilst most earthquakes in New Zealand are the result of sudden release of kinetic energy, it is also susceptible to slower faults of greater complexity. In 2016, New Zealand experienced its largest on-land recorded earthquake in the country's history, with a magnitude of 7.8 on the Richter scale. This earthquake triggered a slow slip movement of the tectonic plates, increasing the potential of further large earthquakes. Slow slip events are relatively new to geology, with seismologists at the early stages of understanding the complexities between slow slip events and earthquakes. One of the most recent examples of the devastation caused by earthquakes comes from Christchurch in 2010. Of the thousands of earthquakes that impact New Zealand every year, one in particular devastated southern New Zealand and continues to have aftershocks even to this day. A 7.1 magnitude earthquake struck Darfield, Canterbury, in southern New Zealand. However, there were little casualties because it occurred so early in the morning and the shaking wasn't severe enough to topple structures, but only caused minor damage. On February 22nd of 2011, one of those aftershocks hit 10 kilometres south of the Christchurch Business Centre at around noon. With a magnitude of 6.3, the aftershock wasn't as powerful as the original earthquake. However, the fatalities reached 185 people, with thousands injured. Since the earthquake happened during lunchtime, the streets were crowded with people and cars, so when it began, surrounding historic buildings collapsed under the severe shaking. The Canterbury Television and Pine Gould Corporation suffered most of the casualties, as the building collapsed with people inside and on the street. A total of 130 people were killed. Other fatalities and injuries happened from rock cliffs breaking, buildings collapsing, and car accidents. The reason this aftershock was so destructive is because the epicenter of it occurred at a shallow fault line, inhibiting more violent shaking than the earthquake in September. This provides a great example of how aftershocks can sometimes be more destructive than the original triggering earthquake. Since this event, the surrounding areas have experienced tens of thousands of aftershocks, with geologists predicting that thousands more will happen with the potential of similar magnitude. Although the concept of earthquakes usually has negative connotations with devastating effects, they are also responsible for some of New Zealand's most beautiful landscapes.